Good morning, students. Today's topic is the composition of functions to verify inverses. Yesterday, we talked about the composition of functions is a way of joining two functions. The input of the first function is then has the function become its output. Then the output then would become the input of the second function, and the final output would be in this range. Domain range. This range becomes the domain of the second function, and that is the range of the second function. Hope I didn't mess that up. Okay, in inverses, all that idea was that if the domain of one function brings us to the range of the second function, and the inverse of that function would just bring us back to where we started. So if we link those two ideas together, then I'm going to come up with this rule, this statement. If the composition of f of g of x is x, and the composition of g of f of x is also x, then f and g must be inverses of one another. Okay, why is that so? Well, basically, if the f function starts off with x, basically describing this one first, if the f function takes f to some output, and the g function is the inverse of that particular function, then it doesn't matter what the output actually was here, because it's going to bring me back to what I originally started with. What am I starting with? X. Okay. So let's take a look at some examples. So this looks very similar to homework number, whatever 2 homeworks ago was, where I asked you to find the inverse of a particular function. In this case, I'm actually giving you both functions, so this seems to be an easier question. Just verify that they are inverses of one another. In other words, if I do f of g of x, I should end up with x, and if I do g of f of x, I should also end up with x. Let's begin. F of g of x, as you remember from last time, is when we start with the g function, and then we take the output of that and enter that into the f function. Another way of thinking of that is start with the main function, the f function, and that has the g function substituted into the input of the f function. Wow, that confuses me sometimes. So since I said that these are already inverses, then I already know that I am going to get the answer of x. This is really a practice, an exercise of operations. It's really about how do I show the order. Well, the first thing that would go is not something that's tucked in the middle, but usually it's, if you're just trying to simplify, I'm going to multiply the 3, and it's going to distribute to the parentheses, but it's really just going to cancel out that denominator. X minus 5. Bring down the other term. Combine like terms. And I'm left with simply what I wanted, x. So far, so good. It's not commutative, so we should show it both ways. This time I'm placing the f function inside of the g function. So I'm going to write the g function. Notice I write the function with a space where the x is. That's the input. And this time the entire f function would be placed inside of that input. In this case, there's nothing to distribute over here. Rewrite that, 3x plus 5 minus 5. The first thing to cancel out this time, in comparison, are the 5's. Bring down the 3x over 3. Slide this up so you guys can see this. 3's cancel, and I get what I knew I was going to get, what I started with, the original x. Okay, check, check. They are inverses. There we go. No surprise there. Showing the steps in that order. Let's try this with a cube and a cube root. Composition of f of g of x is placing the g function inside of the f function. Notice I wrote the entire f function, but with the g function, with the x removed, and then the g function is substituted inside. What cancels first? The cube root and the cube. What cancels second? The addition and the subtraction. Check. G of f of x. This time I am writing the g function as the main function. Leave a blank where the x would be, that is the input, and the f function is substituted inside. Nothing to distribute. The 7s cancel first, and the cube root cancel second. It's really about the order. Check, got the x that I needed. Looks good. These are inverses, verified. Okay, see if you guys can do a similar verification of inverses in the assignment labeled number 12. Thank you. You can do it.